Hello everyone, good morning. My name is Oscar Lima, I'm from Instituto Superior Técnico, Lisboa. So today we have a demonstration for you about a controller that was developed by a master thesis student at our university. So this controller, it's moving both the arm and the base combined together to achieve a goal pose. So first we would like to present an overview of the controller. So what are the inputs to the controller? So we have a goal pose for the end effector to achieve in 3D space. We have as input to the controller the current end effector pose, and we also have the current joint states. So these are being reading from in real time from the motor controller. So the output of the controller are velocities for each of the joints of the arm. So there are 7 velocities. We have a 7 degree of freedom arm, so we have 7 velocities for each of the motors as output of the controller. Plus we have velocities for the base in X, Y, and theta. So how the desired velocity is calculated? It's just a difference. So you have the goal pose, you have the current end effector pose. You subtract these two poses, and you have basically a velocity vector of where you want to go, where you want the arm to go in 3D space. So it's a Cartesian controller, what we are doing. But next slide. Yeah. So this controller is made based on optimization. So this is how we calculate the Jacobian matrix. So we use PyKDL to parse the URDF model. And from the URDF model, we extract a kinematic chain. This kinematic chain, it's, next one please. Yeah. So this kinematic chain, we use it to control the Jacobian. And then by using this Jacobian, then we are able to drive this arm. But this is an optimization-based approach, as I told you. So we have a cost function, and this cost function is trying to be minimized all the time. So let's forget about the maths for now. Let's start with the demo. Yeah, can we start?
Let's go.
So the robot will drive to the location of this small table over there. There we have prepared a Pringles object. It has an Alvar marker attached to it. So the robot will perceive this Alvar marker. It is important to mention that this cable that we have connected to the robot, it's just for being able to stream high-speed data in this screen so that you are able to see what is going on. Yeah, please. So the robot looks at the marker. The marker is being detected here as a pose in 3D space. The robot undocks the arm successfully from its shell, opens the gripper, and now it's running the controller right now. So the controller is moving the base and the arm at the same time, and it's trying to achieve the position of the object. Yeah, we're ready. Let's go. So the robot will now grasp the object. It will lift the object. Now it has the object.
I grasped the object.
And we have concluded the first half of the demo. For the second half of the demo,
I am going to look now.
The robot is going to a predefined location where the operator is going to be waiting for the robot. And here we present a second use case of the controller. A second use case of the controller is for the robot to put the Pringles inside the pink bag. So what we are having right now, if you see, so this is the pink bag. This is the output of a convolutional neural network, which is running YOLO. The robot is trying to achieve the pose. It's moving the base and the arm combined. So how do we do this? Because YOLO is a 2D detection base. So how do we extract the 3D from the 2D? So we have this component that it's able to map from 2D information, it's extracting the point cloud to get the depth. So from a 2D bounding box, we calculate the center point, and the center point, we take the point cloud associated with it. So you see the robot here is trying to match the end effector pose with the pose of the back that is actually being updated in real time. And the robot is trying very, very hard to reach the back. Okay, let's be nice to the robot.
Please open the bag.
Please open the bag. Open the gripper. And the object is in the bag.
Your attention.
Thank you very much. I will take time for questions now.
There was a moment at the end of the demonstration in which the arm, the way that was positioned, was blocking the bag. And unfortunately, even though the young gentleman was over there, because he couldn't see the bag, I'm guessing that he thought, well, the bag's still here, so I'm gonna go this way. Is there any way that you are considering to maybe cancel out the arm visual data to get because you're literally blocking your own sight towards that bag? So is there any thought in how to remove the arm to do that?
Yes, so this is actually one of the main problems of the controller, because it's having perception on the loop, and we need to see the object to be able to get this 3D pose. And if we don't have this pose, then the best we can do is, first of all, we can run a tracker. So we can put some tracking mechanism there, which is able to predict, based on previous velocities of the object, is able to predict in the next time step where the bag is going to be. This is one thing. The other thing we can do is just remember the last pose that we saw, where the object was. And the other thing we can do is just like try to move the base such that the object remains on site. But yeah, thank you. More questions?
What about adding constraints? Because that was holding a can of Pringles, which was closed, but if it was like a glass of water.
Yeah, so the nice thing about this approach is, like, one time Professor Roynings visited Von Rensing University, and he gave us a very nice lecture on manipulation. I remember 3 years ago or something like that. He said, everything in robotics is a constraint optimization problem. And just now it clicked into my mind. And I mean, it is.
Would you ask questions from Gerhard?
So, sorry, just to finish answering the question. To finish answering the question, is if you have an optimization approach, it's very flexible. So we started the controller just with the arm, and then we added the base. So it's easily extendable. The next step is to add obstacles, and the next step could be to add such constraints, like, for example, to keep orientation of the end effector all the time horizontal, such that you don't drop stuff. So in the controller we have weights. So we have weights for each of the joints, and we have weights also for the base. So if you play around with these weights, you can prefer certain motion. So you can penalize, for example, the rotation of the base, and you can reward the linear movement of the base. Or you can, maybe one particular joint you don't want to move, so you penalize this joint, and the controller is able to calculate. It's a convex optimization problem what we're solving.
First a comment, and then maybe some simple yes/no questions. So the comment is that what Hermann said he did a couple of years ago, and as he changes his mind every 3 months. So To some extent, yes, everything is a constraint optimization problem. One question, do you consider the arm and the base as one integrated kinematic chain? And handle it?
Yes, so...
The next question is concerning to that problem that Caleb and Alex already mentioned. Could you consider imposing constraints derived from perception to do the planning of the paths such that you will guarantee that the object of interest will remain in sight?
Yes, so this controller actually would be very nicely extended if we have other components, like for example right now we are providing as input to the controller a target pose, which is directly from perception. This we want to change. We want to put another component in the middle, which is a grass planner. So from perception you get to the grass planner, then you get the grass power pose, then it's input to the controller. So this is one thing that we want to do. And the other one that you mentioned, right now we just have initial end effector pose and final end effector pose, but we could actually input a trajectory, input a path, so many trajectories, such that we are able to do some motions. For example, for cleaning a table, this controller has many different applications. So one of them is picking, another one is placing, another one is watering plant. You can do many things with this controller.
The time is up. Thank you very much. Thank you very much, SocRob.